Hello and welcome back to JD's Science Prep. Today we're going to be discussing adding and subtracting with significant figures. So in a previous video we discussed multiplying and dividing. There will be different rules while adding and subtracting with Sigfigs. So while adding or subtracting and keeping significant figures, you can only have an answer that is as accurate as your least accurate measurement. So this differs from multiplying or dividing with sigfigs, where the amount of sigfigs in the numbers being multiplied or divided will influence the sigfigs kept in the final answer. So we're going to go over 4 examples here. I'm just going to zoom in so we can get a little bit of a better view. The first example we have is, let's say we took a measurement of 1.002 meters and we want to add it to a measurement of 7.2 meters. So let's discuss the accuracy of these two measurements here. So in 1.002 meters, we are accurate. Let me zoom in a little bit more. We are accurate to the thousandths position. Let me just erase this. I'll make it a little bit neater here. So we are accurate to the thousandths position. Okay. And if we look to our other measurement, 7.2 meters, we are only accurate to the tenths position. Okay. So again, the rule while adding or subtracting, we need to, we can only be as accurate as our least accurate measurement. So as we can see in this number right here, we are accurate to the thousandths. And in this number here, 7.2 meters, we are accurate to the tenths. So that means that this is our least accurate measurement, and therefore we can only keep significance for our answer up to the tenths position. All right. So let's add these two numbers up here. And if we were to just take the straightaway answer, we should get, here I'll put it a little bit larger, bigger font. We should get an answer of 8.202 meters. So again, if you type it into the calculator, that's what you're going to get. However, if we are keeping significant figures, we can only write 8.2 meters because we can only be accurate. We can only keep significant figures to that tenths position. Okay, let's take a look at number 2. We have a measurement of 86 meters, and it's being added to a measurement of 10.4 meters. So again, let's zoom in and see what we are accurate to on these two examples here. So for 86 meters, we are accurate to the ones spot. We are accurate to the ones spot. And on 10.4 meters, we are accurate to the tenths position. So if you ask yourself, which number is more accurate, you should say that 10.4 meters is more accurate. Okay. That makes 86 meters our least accurate measurement. Okay. So we know because of that, we can only keep our answer to the ones position because that's our least accurate measurement. So if you type it into a calculator, if you type 86 meters plus 10.4 meters, you should get an answer of 96.4 meters. But we can only keep Sigfigs to that ones position. So we have to round down to 96 meters. That should be our answer with significant figures. So 96 meters. Okay, let's move on to a little bit of subtraction here. Okay, so we have 54.8 meters subtracting 25 meters. Okay, so if we take a look at this, let me just zoom in one more time. 54.8 meters. We are accurate to the tenths. We are accurate to the tenths position. If we move on over to 25 meters, we are accurate to the ones position. And I want you to ask yourself, what should we keep Sigfigs to in our final answer? And if you said we should keep Sigfigs to the ones position, you would be correct. Okay, so if you type this into your calculator, you should get an answer of 29.8. Okay, so again, that's without Sigfigs. We can write down that answer. We can say 29.8 meters, but since this is a subtraction question, we have to be as accurate as our least accurate measurement, which is 25 meters. It's accurate to the one spot. Okay, so we can say this is 30 meters. We can round up. Now, this is a little bit of a tough one, because if you round up, you find that it will result in 30 meters. Okay, so we can either write it like this, or we can say 3.0 times 10 to the 1, which just results in this 0 right here. It lets people know that this is an accurate 0. This isn't rounded. This is not a rounded 0. It's an accurate 0. Okay. All right, the final example here, we have 7.602 meters, and we are subtracting 2.77 meters. So we're going to do the exact same thing as we've been doing before. Let's see what we are accurate to in our measurements. So we have 7.602. We are accurate to this 2 right here. So this is our thousandths position. And in 2.77 meters, we're accurate to this last 7 here, which is our hundredths position. Hundredths position. Okay. So again, we can keep Sigfigs up to the hundredths position in our answer. So if you do type this into the calculator, you will get an answer of 4.832 meters. So we can write that down here. Oops. So we have 4.832 meters, and let's take significant figures into account. Let's be accurate to the hundredths position here. So you should get an answer with Sigfigs of 4.83 meters. As it's accurate, again to that hundredths position. Okay, I hope this video helps.